All right, my little friends, it's time for our daily bell ringer. Bell ringer, bell ringer. Come on, let's do the bell ringer. All right. Hey now. Mr. Kovacs Class. It's Mr. Kovacs Class. You might learn a ton. It's Mr. Kovacs Class.
It's interesting too.
It's Mr. Kovacs Class.
And he's super cool.
It's Mr. Kovacs Class. In the beginning, the earth was a terrible place. Some may argue it's still kind of a terrible place. It's hard to live here on planet Earth. But man, it was hard to live on planet Earth when at the beginning, 4.6 billion years ago. It was like incredibly hot. It was so hot that there was no liquid water. All the water was vapor. There was no oxygen in the atmosphere. It was being struck by meteorites and rock particles, and there's volcanism. And I mean, it was a horrible place for about 1 billion years. And then something weird happened. Life began. And two things we could say about life. One is the earth has shaped life, right? But life has also in some ways shaped the earth, at least its climate. And we're going to talk about that as we discover how this great diversity of life on earth has come into existence. All right, earth shapes life. More in particular, the chemistry of the earth shapes life, especially when you talk about the atmosphere of the earth. In the beginning, right, if you look at this, in the beginning, the gases that made up the earth's atmosphere are very different than they are now, okay? And so that would have had an effect on things. In fact, it wasn't until about 3 billion years ago when the water vapor left the atmosphere, and because of the cooling of the earth, left the atmosphere and settled in liquid form on the surface of the planet, did we even have any inkling of any life forms. Okay, that's because we know now that water is such a key component of life. Water is the universal solvent because water dissolves so many particles. Particles from the atmosphere can dissolve into water. You can have things like nitrogen and nitrogenous compounds easily dissolve into the water. And that made this kind of like primordial soup of oceans with the stuff ripe for life. Okay. The first signs of life was about 3.5 billion years ago. We find the first fossils. Now the first fossils, they weren't very much, right? The first living things, they look like basically bubbles, right? Bubbles. They were made up of membrane on the outside, lipids, just lipids. We know that lipids don't mix with water, so they tend to bind together. They tend to bind together in circles. If they bind together in circles, they may trap some water inside of them. If that water has chemicals in it, those chemicals would be inside of that and might even be at a different concentration inside than outside. Right? The first living things were able to trap chemicals and then utilize those chemicals. Certain ones we know already as like the carbohydrates, proteins, lipids, and nucleic acids. So somewhere along the lines, it's conceivable that the early Earth, its atmosphere, once there was water on the planet, we could dissolve chemicals into water, things like ammonia and long chain fatty acids and phosphoruses that would normally be floating around the atmosphere. And once they're there, they can recombine. Once they're in the ocean, they can recombine with other chemicals, lots of different ways. That's not life, that's just chemistry. Right? And of course, lipids tend to circle on themselves, right? They tend, because they don't mix with water. So maybe they trap some of these chemicals, and eventually, we know this has happened. Eventually, some of the chemicals were trapped that were able to copy themselves. They're like RNA, and then ultimately DNA. And once a cell could copy itself and make new versions of the cell, now we had life on Earth. That was about 3.5 million years, or billion years ago. So, way long time ago. Since then, we've had tons of diversity of life, right? But we've also had like explosions of life diversity, and then time where there wasn't much diversity, and then re-explosions. And all as the planet changed its climate and its environment. Sometimes that was caused by the life themselves, like the evolution of cyanobacteria increased into a massive influx of oxygen in the atmosphere. We know oxygen oxidizes chemicals. It's poisonous to a lot of things. In fact, at the time, it was poisonous to like 95% of life that was on Earth. The only ones that survived were the ones that had adaptations to survive in an oxygen-rich environment. That's like us, right? We've had like the Carboniferous period where there was so much oxygen in the environment, it actually sucked up so much oxygen and so much carbon dioxide was sucked out of the environment that there was a cooling effect. Cooling effect, of course, affected the organisms that were living on the Earth at that time, right? And then the ones that adapted survived. The ones that were not adapted didn't survive. That's the importance of sexual reproduction, right? So your offspring are not all exactly the same. When there's changes in the environment, that's important to have differences in your offspring. And anyway, now we're about halfway through the life of the Earth, and that's when our kind of thing showed up, and that's what we find most interesting. But we're going to talk more about fossils and life on Earth and diversity, and then the mechanism of change. Okay, that's where we're headed. Thank you for paying attention to this Bellringer. Now let's do class.